Today in Capechi's Corner, we're going to look at a similar triangles postulate. The angle-angle similarity postulate states that if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. So if we look at our diagram below, if we can identify two pairs, so for instance, I can see that A and D are congruent, and I can also see that B and E are congruent. Now, if you remember from a previous theorem, because those two angles are congruent, we know that the third angles have to be congruent. So I know that C and F are going to be congruent as well because of the fact that the sum of the angles of a triangle are 180 degrees. That's why this similarity postulate only requires you to show that two angles are congruent. So I can say triangle ABC is similar to triangle DEF. The first question asks, are the triangles similar? So when looking at number 1, I have two triangles. I have triangle ABC, the bigger one, and I also have this triangle here, so I want to see if they're similar. Now the lines are parallel, they're marked, so I know that angle D and angle A are congruent because they're corresponding angles. I can actually say the same thing over here. E and C are also congruent. Now when we're dealing with similarity, the order does matter, similar to when we're trying to prove that triangles are congruent. So ABC is my big triangle. A here is congruent to angle D, so that's going to be my next angle. B actually is a reflexive piece. We're going to talk about that. So that goes next, and then E and C are congruent. So my similarity statement is going to be triangle ABC is similar to triangle DBE. Now I only need two angles in the angle-angle similarity postulate to prove that the triangles are similar. In this case, I actually had another option. Angle B is reflexive. That's actually part of angle BDE, the smaller triangle. So here's my smaller triangle. And it's also an angle in my larger triangle ABC as well. So in this case, I actually had three options, but I only needed to prove two. In number 2, I have two triangles that are both isosceles. So I know that BA is congruent to BC because they both have a measure of 6, which means this angle is congruent to this angle. A and C are congruent. Now, even though in the other triangle, triangle DEF, I also have isosceles, and again, I know that they are congruent. They're both 6, and I know that my base angles are congruent, but here's the problem with this one. Although angle D and F are congruent, I don't necessarily know that they're congruent to A and C. So for instance, if we go to triangle ABC, I could say that the measure of angle A is 30 and the measure of angle C is 30. I know that the base angles are congruent. If I look at triangle DEF, I also know that those base angles are congruent. However, this one could be 45 and this angle could be 45. So I cannot prove for certain that these angles are congruent. So we're going to say that this is not enough information to decide whether these triangles are congruent or not. In looking at number 3, I have that both figures are parallelograms. So I know that opposite angles of a parallelogram are congruent. So that makes this 120 and this makes this 120. But in order to say that the shaded triangles are similar, I need two angles that are congruent, two pairs. I only have one pair right now, the 120. So this I really can't make a conclusion that the triangles are similar, so no conclusion. In number 4, I have a trapezoid, and I know that the bases of trapezoids are parallel, so I can say angle BAC is congruent to angle DCA because they're alternate interior angles. I can say that these angles here are vertical angles, so they're congruent. So I actually can say that these triangles are similar, the shaded ones, because of angle-angle similarity postulate. I actually even have a third set. I can say angle CDB right here and angle ABD right here. I can even say that they are congruent as well because they're also alternate interior angles, but I only need two pairs of angles that are congruent to say that the triangles are similar. Our next problem says to find the values of x and y. So I'm trying to figure out if I can say that these triangles are similar. So I have the bigger triangle ABC, and then I have this smaller triangle above it just to see if I can see if they're similar at all. So this is the smaller one, and then ABC, I need to see if I can prove that they're similar. I do notice that the lines are parallel, segment DE and CB are parallel. So that can tell me that D and see that they're congruent because they're corresponding. I can also say E and B are also congruent because they're also corresponding. So from a angle-angle similarity postulate, I can say that these triangles are similar. Also remember this angle A at the top, it's actually reflexive. That angle's in both triangles. So I actually can prove that all three pairs of angles are congruent, even though I only need two pairs to prove similarity. So I redrew the triangles, so let's see if I can measure them. So the measurement of AC, when I add 9 and 3 together, that's going to give me 12. CB down here is 8, and then AB is going to be 12 plus Y. In triangle ADE, I have AD is 9, and segment DE is X, and segment AE is 12. So now I need to set up a proportion. I can use that 12 and 9 here. They're the measurements that those segments are similar, and I have values for each, so I'm going to use that as my scale factor. So 12 over 9 is the same as 4 over 3. So I can say that 4 over 3 is equal to, now I use my triangle ACB as my numerator, so I just need to be consistent. This is going to be 12 plus Y all over 12. And when I cross multiply, I get 48. 4 times 12 is equal to 3 times the quantity of 12 plus Y. So that gives me 48 is equal to 36 plus 3Y. And 3Y then is equal to 12. So Y has a value of 4. Now I'll do the same thing for X. Again, my scale factor I found to be 4 over 3. And I'll use 8 over X, right? CB is in proportion to DE. So that gives me 4X is equal to 24. So X is equal to 6. And in our last problem today, we're also going to find the values of X and Y. So I have one marking already of congruent angles. I have angle K is congruent to angle L. And I also notice that I have vertical angles here. So I can say that these triangles are similar by the angle-angle similarity theorem. So again, I have three sides here, and I need to figure out what is going to match up with what. So 12 and Y, they're going to go together. I have 18 and X, so I'm going to use 15 and 20. So 15 is going to be my triangle on the left, 20 is my triangle on the right, so I need to use those to get my scale factor. And that will simplify to 3 over 4. So I can use 3 over 4 is equal to, now let's use 18 over X. So when I cross multiply, I have 3X is equal to 72, divide both sides by 3, and X is equal to 24. I'll do the same thing to find Y. Again, here's my scale factor, so I have 3 over 4 is equal to 12 over Y. So when I cross multiply, I have 3Y is equal to 48. So Y is equal to 16.